So this is an Arduino Nano. I need to make some kind of mount for it. I was hoping there would be holes in the circuit board to bolt it down, but it doesn't have it. But I had this, what do you call it? It's kind of a development board. I got a lot of electronic parts when I was 17 years old. That is more than 20 years ago now, so I haven't used much of it, but and I have not soldered electronics since then either, so I'm a bit rusty. Let's see how this goes. It's probably 20 years since the last time I soldered a circuit board, and it shows. It's not the prettiest, but I think it will do. I wonder what temperature I should solder this with. I have no idea. Let's try on one of the digital connectors. I don't need those. Let's try D10, just for fun. Oh, this is tiny. Oh. How am I supposed to do this? I'm sure people are laughing off me now, but like I said, it's 20 years since I've done this the last time. If I add too much heat, the circuit board will dissolve. This is probably super exciting to watch as well. If I was smart, I shouldn't solder all of these before I know that the Arduino works. But here we are. I don't think I will ever get this off without ruining it later, so either it works or it doesn't. These are the critical pins. This is the power or voltage in, reset, I don't need that one, but 5 volts out. That will be powering the potentiometers, the resistors. So I have just hooked up the Arduino to the computer. I'm not even going to try to explain what's going on here because I barely understand it myself. But basically I told the Arduino to sense resistance on an analog input pin and attach that to a digital output pin for the servo. Initially I thought that the analog pins was used for both input and output, but it turns out I need a digital output to control the servo. So I just hooked up with a Milwaukee battery here. So full turn here makes the servo go 90 degrees, now 180 degrees, but I probably only need up to 90 degrees travel for what I'm using it for. So I can change that in the program. So the map is 0 to 1023, that's the resistance input, and 0 to 180 degrees output. So if I change that to 90, hook up the Arduino and transfer. So now I have 90 degrees sweep. So I've just finished wiring up this control panel. It's I wish it was a bit deeper because I had to bend all these connectors in order to gain enough height, but with enough persuasion the lid will go up. The control box is mounted, and I have routed the control cable. So now I just need to connect up everything. I like to always make myself a service pigtail, unless I want to change up something later, so that way the cable is not too short. You get the idea. The control cable is wired up. I haven't tidied up everything yet, but it's a cramped box, so it won't be as tidy as I would like it to be, but that's just how it is. I have started to run the wires to the engine to control it. You have to remove the cover around here. So I made two sets of wires, cables going up. One for the ignition. I also need power to the control box, and for the starter. These twisted cables are for the servo motors to control the carburetor. I haven't filmed much of this because it's just tedious work. It's not very entertaining to watch. So I'm just going to finish this and then pick up the camera again afterwards. It's been sitting for several weeks now. Let's give it a sniff. Let's see if the ignition is wired correctly. Why? The stop solenoid. This engine has a stop solenoid on the carburetor. I don't know if you can see it. That obviously needs power. But still it should start with the ether, right? Why you no run? Okay, that works. It has just been sitting too long and the fuel tank is so low it loses prime. But cables installed with some what are these called? Like a retainer, rubber retainer thing. I wasn't completely thinking when I designed this remote start system. I thought that this engine had an ignition module that needed power to run the ignition. This is just like any other small engine. It's the only way to stop it is by grounding the coils. I don't know if the camera will focus, but nope, it won't. When you put the engine, the switch in off, it grounds the ignition. And in the on position, you run power to the stop solenoid valve. So what I've basically done is that I have connected when I put the ignition on, I send power to the stop solenoid. So in order to stop the engine, I shut the ignition off, the fuel solenoid shuts off, and the engine will starve for fuel for a few seconds and then stop. So the servo will go there. I need to drill and tap these poor little... This will be fun. Safety squints. Okay. So now I have to see if I can actually get the servo out of there. I had to cut the bracket in half because I wasn't able to get the servo out with it in one piece. So let's try some anti-spatter spray. Really didn't want to weld much with the servo in place. Ow! Ooh! Now I can remove the servo. Woohoo! It works! So the throttle is hooked up and works. I'm not 100% happy about it. This servo is slightly too weak to pull the regulator springs. What I will do, I will change out this linkage with some proper ball joints meant for these servo arms and make a solid rod here. That way I don't have the friction in this sleeve, and it's also not straight either. It's a bend to it, so this will create friction. So I'm hoping by making a solid rod, and also there is a bit of dead band here. This is dead band, it doesn't affect the throttle. So if I can calibrate away that, I can use the hole next to it and make the arm shorter and the servo will be stronger. So I think that is the solution I will go for. When it comes to the choke, this is the choke lever. This doesn't require any force at all. I bought this 25, I think, 20 or 25 kilo servo for that, but it's too big, there's no way to mount it here. But I have a bunch of these micro servos. This is super small, not very powerful, but I think it's strong enough to pull the choke lever. And this one fits. I don't know if I can show you with one hand and filming with the other. This fits perfectly underneath the intake here. This cover came off the hand crank for the shoot turn. 17 millimeter. Nej, det kan fan inte stämma. I think we have a rough estimate of how this will look. We're just building this on the fly as we go. Did I make it too short? Yes, I made it. I made it twice. Let's hope it fits this time. Oh yes, it does. Woohoo. Just barely, but that's good enough. Now I wonder if this servo will turn the right way, or the right direction to say. Yeah. Don't remember the pinouts for this. Negative to positive, positive to ground. These wires are on the thin side for these vagos, but for testing everything is allowed. Okay, if I turn the ignition on, give it choke. Yes. This is a piece of 3/16 TIG rod, so I might be able to use that. That might work. Oh! Okay, now let's try it. We need the choke on. Some throttle there maybe. This box is way too small for all the wiring I have in here, so it's quite a mess, but everything is labeled and it corresponds to the wiring diagram. The way I had wired this was that I had wired my ignition signal to the fuel solenoid, so when I turned the ignition off, I basically starved the engine for fuel. It would run for a few seconds and then shut off. But after considering it, this switch is also my emergency stop. If something happens, I can shut the engine off, and then I don't want to have to wait for 3, 4, 5 seconds for the engine to shut off if something gets caught in the auger or something. So I have I didn't want to do this, but I've added a relay here that basically when the relay is not energized, I have focus there maybe, the ignition is grounded, and when I put the ignition on, I energize this relay, and the ignition system is not grounded anymore, so that way the engine should fire. What can possibly go wrong? Yes, theory works. Nice. I feel better about that. It's more safe, or it's less dangerous. If someone told me that one day I would be using a computer to tune the throttle response on my snowblower, I probably would not believe them. So right now I am tuning the travel of the throttle servo. So in order to monitor the maximum speed of this, I'll just glue this reflective tape onto the pulley. Hopefully it won't fly off anytime soon. Hopefully that sticks. Okay, that was over 4,000 RPM. That is too much. Let's just see what happens. Let's give it a few turns here and try again. I also have had the new hoses for the chute made. I made 1/4-inch hoses this time. I'm also going to install adjustable flow restrictors for the turn because the chute is very quick. It's going that way. No, that way. No. Pressure in this way over the restrictor, out that way. I also bought a clamp to clamp these hoses because there's a lot of leverage and a lot of connectors here. So I will probably make a mount for it here somewhere. forgot the cable. That icon shall start blinking if this works. It's done! These are some Velcro bands, so they're easy to remove. The snowblower is done! Wow! That was very anticlimactic. Now what do we do? What's the next project?